All right, and finally, let's take a look at a few of, now that we've worked through the limit problems, it might be important for us to do a couple of the simple derivatives using some of the rules that we learned last week, using things like the power rule and our rules for summation and things like that. So let's start off with 3.2, number 13. So the power rule is what we're going to use for 3.2, number 13. If f of x equals 5x cubed, the nice thing is we did this problem in the previous section. We had to use the limit as h goes to 0, f of a plus h minus f of a all over h, and that became painful, right? The nice thing is now, though, as we look at this, it's actually fairly simple because of what we've shown you with the power rule. So f of x equals 5x cubed, then f prime of x, really, remember what we do is we take the 3, we multiply it down in front. So if it was just x cubed, it'd become 3x squared. But same thing happens. Now we take the 3 down, we multiply it by the 5, so we get 15x. But then when we rewrite the power, we subtract 1 from this power. So it's 15x squared. And you're done. Just like that, the power rule made that problem extremely simple. And in number 16, I think a lot of people look at this and like, oh my gosh, I don't know what to do with this. It's actually still really, really simple. The square root screws me up as much as it screws you up. So it's not really a big deal to concern that. So we're going to write g prime of t, and we're going to get rid of that square root symbol. We can rewrite the square root as the square root of x is equal to x to the 1/2. So we can rewrite this one in similar fashion. 6 root t is also the same as 6t to the 1/2. And now it actually becomes something that you can deal with. Actually this is really me just rewriting g of t. Let me create my mess here that I made here. I'm not a big fan of that. What I really should have done here is I should have just rewritten g of t and said, hey, you know what? G of t is actually also equal to 6t to the 1/2. So it's still g of t. So then what is g prime of t equal? Well, g prime of t, I just use the same power rule I used over here. This is now a 1/2. So I take 1/2 and I multiply it by 6. So I get 3t, and then I'm going to take 1 away from 1/2. Well, 1/2 minus 1 is minus 1/2. And that looks good. Now, I would tell you that I'd be happy with that on the test, but you need to think about what this t to the minus 1/2 really, really means. That the most correct way to write this answer would be to say, you know what? This is the same as saying 3 over the square root of t. So that's like saying t to the minus 1/2. So that looks good. All right, and then finally, sorry about my goofy line there. I wonder if I can fix that too. Eraser. Yep, there we go. And pointer. Just getting used to my. I feel like I'm finally getting used to this stylus here. All right, and then finally on 25. We've got f of x equals all this mess. So what I would do first is I would manipulate the function again a little bit. I'd say, well, what's 2x times 3x squared? Well, it's 6x cubed. And then I'd say, okay, what's 2x times 2? Well, that's plus 4x. And then what's 1 times 3x squared? Well, that's plus 3x squared. And then 2 times 1 is obviously 2. And then I would combine any like terms if I have any, and I might reorder these things. So I get 6x cubed plus 3x squared. I guess there's no like terms, but I am going to reorder this, plus 4x plus 2. So that's my new function for number 25 there that I want to take the derivative of. So now it's just a matter of taking the derivative. So what I'm going to do next is I'm just going to rewrite this as f prime of x. And now when you take the derivative of the polynomial is essentially the derivative of the parts. So 6x cubed, we know how to do that. 3 times 6 is 18. Subtract 1 from the power, it's 18x squared. Plus 3x squared takes 2 times 3, becomes 6. Take 1 from the power there, becomes 6x. And then 4x, same thing, x to the 1. So 1 times 4 is 4. So plus 4. But now subtract x to the 1, subtract the 1 from the power. So I'm treating this like an x to 1. 1 times 4 is 4. And then I want to subtract 1 from the power, becomes x to the 0. So I could write this as x to the 0, but I know x to the 0 is just 1, so this just becomes 4. And the derivative of a constant is just 0, because as an example, y equals 2 would have a slope of 0. So there's your final answer for number 25.